we do have an update on this design guide. I'm going to run through a bit on this design guide and see how this design can actually help you to sell more advanced application together with some pull-through of advanced metering offer, protection relays offers, which is eventually connected to the software for visualization. Okay, let's get started. So why this application approach are so important for digital power system? Because first of all, is the data are becoming more and more critical to many facility operations, right? So we are talking about facility, we are talking about buildings, all right? So only useful if you have a right data from a proper location in the electrical system. So you need to make sure you have the right devices, sensors that put at the right location to collect the right information, right? And then of course, understanding the architecture is important because eventually this enables you to provide some information from the data that you collected. And this data could be very complex, all right? And you need to have some sort of software to be able to sort out all this information and visualize it in a proper way so that you can make good decisions, all right? And then, of course, application approach start with the end user's need. So we are not so much in terms of selling a product feature, a software features. What we are selling eventually really is the applications, and what this application bring is the value proposition to the end user. And this data eventually allows the end user to visualize, to look at things much simpler and provide some analytics so that to allow them to facilitate some decision making. So imagine you have so much raw data coming in from different devices at different level of the network. Things may not be so easily be visualized if you don't really have a good software application approach to simplify the information. And then, of course, eventually is to understand how to optimize your CapEx without sacrificing all this data which is usable. So more importantly is that with this application approach, besides just selling the end user values, but also important to understand how to deploy it in a more efficient way, cost-effective way, so that this will help to optimize CapEx for sure, right? So in the projects, and then to make yourself even more competitive when you're in the market, when we are talking about all these system solutions. So this digital application design guide is basically an end-to-end approach. Okay, when we say end-to-end approach, which means that we have tools that help you to understand what is this application all about and how to present the EcoStruxure power application. So this is under the category of promote and sell. Okay, and then of course we do have a demo. All right, when we click on this, you can actually pop out a demo. And this demo is our online demo that help you to explain about the application and where customer really see it and appreciate it. A lot of times is that when you're trying to sell an application or even a software, it's not easy just to elaborate things in PowerPoint because customers see it, feel it is where they decide whether go or no go, right? So it's important that you leverage a lot on the demo to help you to promote this EcoStruxure power application. So demo related to dashboard or demo related to reports, all right? When we want to deliver an application, for example, a utility bill verification, we are basically putting a shadow bill next to the utility bills. When you look at this one, it's a utility bill that you're getting from every month from the utility company on the energy consumed. And this is a shadow bill, all right? So we are actually comparing the billing of the utility to verify the billing to ensure that you are not being overcharged and is actually complying to your contract agreements with the utility companies. So we have this kind of applications that has been developed as well in this part of this EcoStruxure power digital applications. Okay, so when you move to the next stage, next category will be more design and code. All right, design and code is basically giving you some guidance, in terms of how you actually deploy the applications. what are the things that you should consider, you know, when you design a systems, right? You know, for example, from the selections of the hardware and software, which is probably the last piece. The selection of the application will be the one that comes first to fulfill the customer requirement. And then from there, what will be the kind of communication architecture you should look at, right? So this is part of the design and code. And then, of course, you also have some guidelines to talk about commissioning estimate. How much time do you require to commission these applications and how to do about it? So there's also a commissioning estimate to provide you some guidance. And the reason why we have this commissioning estimate is providing you the guidance on so that you are not putting a lot of engineering time, you know, cost into a project that actually is quite easy to deploy, right? So to make yourself very competitive. And then, of course, you also have technical proposal. When we promote a technical proposal to our customers, it's not really looking at a quotation, but also what are the functional specifications, the functional of the systems, right? And what does it comprise of, these functional schemes? So this is also very important when you promote, because when you sell application, you are actually selling a functional scheme, right? And then, of course, from the functional schemes, then you decide what are the offer that is able to meet those functional schemes. Then, of course, when you go to the last category is to install and maintain, then we have all these deployment guides to teach you actually how to deploy all these applications. So more and more, all these are very systematic, right? I mean, when you look at the three categories, how you promote it, how you design it, how you install and maintain, all these have documentation to guide you through. So that is where we talk about end-to-end application approach. So I just want to run through a bit on this guide. So the guide actually started from end users' needs. It's not started from a product or software, it's from the end users' needs, right? So from the end user needs, then we start to select the applications. Okay, so that is where we talk about this part, the applications. So from this application selected that fulfill what the end user wants, right? So we go into how to implement the applications and what are the design constraints, what are the best design architecture, right? So that is part of the implementations, which is part 3 of these guides. And then from this, then you go into the product selection. So in order to deliver the application, what are the products, and in these products, what are the features required, right, to deliver this application? So this is, as you can see, the whole approach is very much different from how we sold system in the past, where we always talk about products, talk about connectivities with the software, and then we just figure out, okay, what kind of report the customer should have. But from the way we structure EcoStruxure Power today, the way we sell system solution is always looking at end user need as a priority. And then, of course, the way to simplify the application is not just to select the product, but really to select the application. Then after that, what are the products required to fulfill the application and eventually bring all the values to the end users. So when we look into promote and sell of this digital application, first is more understanding the needs of the application. In these guides, for example, on the right side, you can see is a power quality monitoring applications. And in these applications, they always have 4 different parts of these applications. First is, what is the context? What is applications for? What is the context of the application? There's a short description. They talk about these applications. Then after that, you will go into what are the problems that this application intend to solve. Okay, and then of course, eventually, what is the purpose of the application? And then of course, the last point will be the output, which what actually you see on this output. By implementing these applications, what actually the customers are seeing and visualizing on the software layer, all right, software platforms. So this is really important to understand these few items on the left, all right, before you feel that this application is addressing what your customer needs are. So imagine that if a customer prefer the applications, there might be a very systematic way to implement it, to let them understand how it's solved, and to let them also eventually looking at what are the receivables from this application. What do they actually receive? That is where we are talking about the output. So an example that I showed earlier, all right, this is a demo that we actually can, when we talk about power quality monitoring, we're actually looking into a few different aspects of power quality. One, it will be more on the power quality performance. So we look at dashboards, look at all the power quality parameters, and then we have color codes to simplify the message by telling if it's green is okay, which is yellow, caution, which is red, means that you have to take immediate actions. So we have color code to simplify. So imagine if a layman without much understanding about power quality, by looking at the color code, they know what are things that is serious that they need to take actions. This is also one way to monitor the power quality performance. Another aspect of power quality will be more on the disturbance direction detection. So this is also one of the way that we actually look at from the single line standpoint, looking at the devices which is just pointing upstream and downstream, that helps the end user to find out where's the root cause of the power quality issues. All right, is it causing by certain loads? Is it causing by utility source? Or is it causing by within the facility, the building, the plant itself? Then, of course, we have all these compliance reports that help to simplify the message to the end user to say, okay, when we are talking about IEEE 519 compliance report, is your electrical system compliant to this IEEE 519? So we do have compliance report that simplify the message, just showing some data. Okay, if you really want to go deep dive into data, you have data, or you just a report showing pass or fail. Of course, when you see a report with fail, means that it doesn't comply. All right, so this is also a way to simplify. Then, of course, another aspect of it is more on how you analyze it. So we have reports that looking at waveform, trending, data that is with a date and time stamping, how often it happens, when it happens. We do have alarms, right? And then, of course, with timelines, where you do all this analysis by looking at all the, when there's any voltage dip happen, you are looking from all the way from upstream devices to downstream devices to understand which are the devices that actually see this voltage dip on the network, right? So we have all these capabilities. And then, of course, we have trends, live trending. So, right. So what live trending does is basically you set your bandwidth or you set your threshold. As long as anything above below the threshold should be good. Once it's above the threshold, something is not good, you have to fix it. So all this can be simplified by by getting a software to to get all these raw data and sort it out so that you are able to visualize it more simply. And of course, on the reporting side, will be more on the verification that I explained earlier. We have many different promotional tools on the exchange today that you can leverage on. All right, some of these promotion tools are talking about sales presentation. So we do have end user sales presentation materials that you can use to promote EcoStruxure power, the digital applications. And of course, in this digital application, we split that into two different parts. One is more on IEC application, which means that in those countries who are adopting a lot on IEC standard, you should, as much as possible, using the IEC application. Or those countries who are more in NEMA standards, then you apply the NEMA application. There are slight difference between these two. There's a reason we have these two documents. Then we have e-brochures, which you can use it to broadcast to the end user to promote the EcoStruxure power, right, to the end users. And then we also have testimonial. So we do have some of these customer testimonial to get some good success that we have implemented and the values the customer are getting from this digital application for EcoStruxure power. So this is also available as well on the portal. And then, of course, the last thing will be white paper, right? So when we talk about white paper, we are always leveraging on technology. So what are the technologies that we have put inside this digital application, which are very differentiated, all right, so that you are able to bring more values to the market, right, through a white paper. So these are some of the promotional and sales content that can be found on the exchange. So the next thing will be more on the designing the digital application. So we already finished the promote and sell. Right now we move into the how we design the applications. To understand this design guide, design the application, there's a lot of considerations, all right, in the design guides. So one of the a few considerations, for example, for communication, how do you build your system? What kind of communication is required to get the best performance, right? So you need to know the communication and data recording and timestamping. So it's important is that what kind of electrical parameters and what kind of frequency of data recording and timestamping they require, so that you are able to capture this event and put that in a way meaningful for you to make certain decision when you found there's some destruction in your electrical systems, all right? Then, of course, how the data is being processed. So there are a lot of different ways of processing the data. So you need to consider how this data is eventually going to be processed. And then, of course, the data integrity, integration, and all right. So it's important that all the data you need to understand. Some data are not so easily just a Modbus registry polling, and some really need some kind of data integration capabilities, so that you are able to put things into one single picture to be able to analyze and visualize. So that is also data integrations and interoperability is very important. Then the last thing, cybersecurity. So are you building a platform, a system that is cyber secure, or you're just putting a system for measurement and control and for analytic purposes? More and more of cybersecurity are getting very important. It's a big trend right now in the market where, you know, every system that you build on, everybody is looking at cybersecurity compliance, especially when we are looking into IEC 62443 standards. The first question is always asked, you know, we have IT side on the cybersecurity and we have OT side as well. So all the devices, software are classified as OT, right? But OT is also important because more and more of these requirements on OT side, not looking at really at not only at the system level, but even at the product level, they are expecting some compliance on the cybersecurity as well. So in this digital application, you also describe the data input. All right, what are the data inputs are required for the application? As you can see on the right side, you see the inputs from the electrical network eventually are talking about things about IOs, things about measurements, things about waveforms, events. These are considered inputs. And how is it going to transfer to your data recording and timestamping? And then eventually the output will be showing you a table of alarms or event or waveform or some analytic tools or reports, you know. So these are part of the functional schemes of the applications, okay? So different devices definitely have a different measurement capability, IO capability, power quality event capability. So it's really important to understand what are the inputs required from the end user and then what are the output they're expecting. Then from there, then you need to make sure that when you design your system, you have the right offer, right products that is able to deliver the input and eventually the output, okay? And then of course you break down all this data into times, what is it going to record, where is it going to record, the timestamp, the recommendation of time synchronization. So these are some of the consideration factors as well. Then of course, details on where the data is going to process, okay? Some data can be processed from the meter itself, from the devices, where the devices itself have like a PLC capability. For example, for ion meters, you can use the ion framework that you can input data into the ion framework and then you can trigger an output. So the processing part is actually done on the onboard of the meters, right? But of course, there's another part of the data process that could be done at the software layer, all right? Which means that all the data come in as a raw data, and then you are just putting a formula in the software to do all the calculations. So the processing part of the data is done at the software layer. So there's two different ways of doing it. Of course, if you do it at the software layer, to me, I feel that the cons is also once you have a communication broken, all right, means that there's no data flowing from the hardware to the software. Means the software don't receive any raw data, they can't process the information. But if you look at do it at the hardware level, it's more secure, all right? Which means that unless really the voltage and the current is totally out, then the meters are not functioning well. Then you can't do much calculation. But as long as the voltage, the current, the control power to the devices are good, everything is done at the hardware level. And if you have all those hardware with onboard memories, you can actually store this information inside the onboard memories. So you don't really rely so much really on the communication network. So when the data is formed, you just send back the data to the software, right? So you are not really so vulnerable to all these communication outages that you cannot send data across and then you lost the information. So this is also part of the consideration on design. Then of course, understanding what are the end users features are. What does the end user want to see eventually? Are they looking at things, for example, real time? Are they looking at things like alarms? Are they looking at things like reporting or any analytic tools that they're looking at? Then that is where you start to develop these reports or some of the trends, some of the dashboard, so that the end user will be able to simplify his visualization and analysis, right? And then, of course, when you develop all this information, it will be more like a real-time updating. So whenever they look at the dashboard, it's always the latest data that they are looking at. Okay, so this is also one of the things that you have to consider. And then, of course, when you come into digital advisory service, which is really the power advisor, that is the part that you probably need to provide the services to these customers, all right? Looking into all the system health, network health, all these services offered. Then, of course, part of the design is also looking into, the selection of the devices, right? So when you move into, once you understood the communication, the end users' needs, what kind of feature they want, then you have to start looking into the selection of the products, right? So what are the devices able to deliver this kind of output at the different part of the electrical network, right? So looking at medium voltage incomer, outgoing, low voltage incomer, outgoing, and all the way to final distributions. So in order to understand the requirement and the selection of products, it's really important is that at different part of the network, what are the devices are required to produce if purely for energy management, looking at kilowatt hour, voltage, power, these kind of parameters, or really looking at power quality. So if you really look at power qualities, then you certainly need to put a power quality meters where not looking at just total harmonic distortion, but also looking at waveforms, analyze the waveform in terms of when there's any surge or dip happens, what are the duration of the surge or dip, what are the magnitude, all those things. These require devices that is able to capture waveforms. Okay, so this is part of the selection criteria. But of course, when you go all the way down to final low voltage, this part, when we are just talking about load monitoring, purely just kilowatt hour, probably a bit of power, then you can use certain devices like, for example, power tag, or maybe some of the single phase IEM meters to monitor the energy consumption by the individual loads. So at different part of the network, depending on the kind of information the customer is expecting to see, that determine what are the devices you should select on the different layer of the network. Okay. So once you start to look into this selection, then you also started to look into communication architecture. Okay, there are some devices that are communicating in serial communication, and some of them is even wireless. For example, power tech. And then, of course, there are some advanced metering products or protection products, devices that have built-in Ethernet communication. So you need to know, how you are able to connect all these devices. Of course, certainly, my advice is that when you come into waveforms, it's always best to go direct Ethernet communication because of the speed of communication. But if this is purely just talking about simple energy parameters, register-based data, then you probably can go for serial communications, all right, by using a Modbus RTU protocol. So there's a lot of consideration factors when you come into communications, all right, but you don't use advanced meters where they have built-in Ethernet, but you use serial communication. You can do it, but really not advisable because the data of waveform files, onboard memories, data, all are really very heavy data, right? So if it takes time for them to pull this information to those bulk rate of 19,200 bps, it takes a while. All right, so it's not so advisable. So normally when you come into all these advanced metering offers or protection offers, where they have a built-in Ethernet port, the way to connect back to the system platform, edge control software is certainly Ethernet. All right, so simple meters without Ethernet means that they don't have all these waveform capabilities. It's purely just data, register-based data. Then you can use a serial communication. And also remember, a lot of times is that we are trying to maximize serial communication through a gateway. And of course, again, as I mentioned earlier, we have a lot of design guide based on segments. Okay, so reference guides. So one of the things that, for example, we do have all these packages, references to talk about large data centers. How do you apply this kind of architecture into the large data centers, large hospitals, hotels, all those, and all this is all available in the exchange orders. All right, so it's very important that you come across all these opportunities in your countries, and it's good for you to learn a bit in terms of how you optimize your design, what kind of tools require, not looking at just design, but looking at the cost perspective as well. But if you have an efficient design, definitely you bring down the cost and make yourself even more competitive when you're bidding for a project like this. All right. So look into all these considerations, reference guide. The whole idea of all these reference guide is basically to simplify, all right, the deployment, okay, in all these segments that I mentioned earlier. So if you bring values to you, definitely you will when you bid for the projects, you will be very competitive because you are really optimizing it. So these are some of the reference that you should leverage on. So we also have some other tools. I'm not sure whether you come across this thing called scope of work package. Okay, so we are starting to build application into understanding what is the scope of in this application. So we are starting to build more. So we started with thermal monitoring and utility bill. Now we have a few more, all right, into it. And then in this scope of work, it actually highlighted very clearly that in these documents, it mentioned about some of the checklists that you have to go through, for sure, all right? And then how much time do you require, all right, to deliver these kind of applications? And this time, as you can see, is all stated here, okay? So if you are doing all these reportings and building these applications, it's good that you go through all this scope of work, all right, just to understand, to make sure that you simplify your scope. Don't add a lot of additional things because of unsure, because of risk, all right? If everything is documented nicely for our partners to use it, then you should, as much as possible, leverage on all these tools to help you. And then, of course, and also on all these tender proposal, all right? So these are part of the documentation we have as part of the design phase, okay? And really it's good for you to leverage on all this documentation to help you. Some of these things is, as I said, is functional prescription. So it's good to add all this functional description into your proposal, so the customer really understand how you're going to deploy it and what are the output eventually they're getting, right, as part of the proposal. That will be actually very perfect, you know, besides just the pricing part. Then when you come to install and maintain, okay, then we also have a tech list, all right, on how you deploy it, all right, what kind of licensing, software license that you require in order to deliver those kind of applications. So it's good that if you are very much application oriented yourself, it's always good to run through these documents and then roll through the checklist to make sure that you include all these software modules and some of your engineering estimate, commissioning estimates into your proposal. All right. The whole idea is not to, you know, increase your engineering cost, because there's a lot of uncertainty in the proposal because you're not sure how to do it. So I think it's good that, you know, if Schneider, we are able to document all these things and giving you and commissioning time estimates. Roughly, this will be the amount of time required to deploy these applications. Okay, so it will not be too much difference. Then, of course, the last thing I wanted to highlight is that whatever I share to you now, we actually record this in a YouTube, which is the link is right here. You can actually look it at the YouTube level. So basically, it's a kind of like learning tools to help you to understand how to use this guide properly. So this is something new. We just did it probably like 2 months ago. All right. I think in the past, most of these guides are being explained through PowerPoint. Now we have a recorded version through a YouTube. All right. So you can actually run through these videos and to understand a bit more on the conceptual and how you utilize this guide more efficiently. All right. And again, is that the whole idea of the design guide is really to simplify the deployment of the digital power applications. And also at the same time, you know, we do not want our partners just to sell product and software. It's really selling applications, selling solutions, and how to address customer needs with those applications before we go to the last stage of the selection, which is products. All right, so this is really, really important. And this is also a big paradigm shift. I mean, people were so used to selling product and software, and moving into application was really a big shift. I think this way of pushing application solution will be bring more values, all right, to the end user eventually. And then of course, we are not so much, not so much in terms of price issues, you know, in the market where people are pushing more on product and feature. We are more pushing on application. So that is one of the things that we have made our shift into all these digital application to enhance our offer in the market. At the same time, to help our partner to sell more advanced offer, advanced metering, advanced protection relays, how we connect them to a software instead of just pushing a product by price and by features. Okay.